And this is part 4 of our lecture on GLHEPRO inputs, specifically the loads. And in part 3, kind of went over this demo, which is for a building, a state park lodge in southeast Oklahoma. So it's really like a small hotel, small motel. And this is the live demo portion where we'll do this well, we'll use the peak load analysis tool. First, we'll find it, and then we'll paste the loads into GLHEPRO and take a look at it. Okay, so I thought about a starting point for this, and I think the best place to start is probably with finding the peak load analysis tool if you have GLHEPRO. So let's see, let me make a directory over here. This is my C drive, and in program file it's x86. There's a GLHEPRO directory. In that directory there are three files that you can copy. I wouldn't take them out, but they're the peak load analysis tool itself, and this quick start guide, and the manual. So if you need those, you can get those from here. I'm going to move them into another directory. Just make one called demo so that we can work there. And when I say move them, copy and paste them. Okay, so here's the peak load analysis tool. Okay, it's giving me these Excel security warning. I'm enabling the macros, and I'm sorry I had to do that off screen, but it wouldn't let me move it over to show you. Okay, so we have to fit this to the window we've got open. Okay, so this comes with some data already in it. So it's irrelevant to what we're using. In fact, there's something funny about this data. I noticed that it shows us the peak load being about 2 watts, so I'm not even sure where that came from. Maybe if we feel better, we'll delete it right off the bat. Okay. So I've got the loads from Energy Plus, and they're in another file here, so I'm going to just copy and paste them in. It's actually got the date and time already in it. There, we might want to plot that. So just come over here while it's all selected. All right. So we've got the heating loads here, and as I told you, Energy Plus has a convention whereby the cooling loads are negative. And you can convert, if they're positive, you can paste those into this tool. It will figure out if they should be positive or negative, and as you'll see below, it treats them, it sort of assumes they're negative the way it plots them. Okay, but there's the loads over the year. You can go back to the part 3 and look at those. So there's several steps here. So first, if we just scroll down, if you just take a look at that heating load profile, and you see it only about 0.002 kilowatts for some reason, if we compute the peak days, we should get something totally different, and we do. So we've got a peak heating load. It's fairly high in the morning, about 105, 106. Then it drops during the day, and then it comes back up in the evening, and it actually hits its peak. Okay, this is showing hour 23 is the peak load, 110.8. Okay, and the cooling load, yeah, so this is one funny thing. It plots it assuming that they were negative, so it shows it being from 0 to negative 120. So you think the highest cooling load should be in the afternoon. It is. It's just sort of inverted on this plot here. Okay, so these are the loads for the day. And then if we, the next step is to do this analysis. And these results are for the previous load, so don't worry about those yet. So we could put in heat. I think we've already figured it, that peak heating duration. Actually, I don't remember now exactly what it should be, but it's not 4, 5, or 6. So let's just try 7, 10, 13 to kind of get a wide range. And it's not 2, 1, or 9. Let's try 6, 8, 10. I think this will bracket the loads, but you can always start with 1, 2, 3 and see it's too low, it doesn't work, so we can go on from there. Okay, one thing about the tool is it has two ways of computing the peak load. It can either take the actual peak and take the 3 hours, or say the 7 hours containing the actual peak, take the average over that, and then use that as the peak load and then compute the response, or it can take the maximum. I think when we originally envisioned this, it seemed like it was a good idea to have both possibilities. But my experience over the last 10 years or so is I seldom find any reason to use the average over the duration. I always use the maximum over duration during the duration. I would use that if I were you too. Okay, so if we calculate the peak responses, come back, there's the heating load profile. Here's the heating response, and you'll see it's been normalized. You'll see this plot has delta T over delta T max. So for heating, it's actually going to be a negative, right? The temperature is going to drop during the peak day, right? So the delta T over the peak day will be negative, but the delta T max, or the maximum of the absolute value, will also be negative. So when you divide the two, you get this normalized response. So 0 is no change from the month-end average, or the month-end heat pump entering fluid temperature, sort of that value computed as if there was no peak loads, and the actual peak day, which is assumed to be on the last day of the month in this tool. We've lost part of the legend, so you can get it back by pulling that down. So you see 7, 10, and 13 hours. Actually, it looks like 13 hours is about right. So we'll check 14 or so to see what's better. Now, if you look at 6, 8, or 10, see 6 is a bit low, 8 is a little bit low. See if we can zoom in on this. And 10 is a bit high, so we might want to look at 8 and 9. It's a little bit hard to hover over anything but the last series plotted. But so that's to be about, you see 1.018. That means that a 10-hour maximum peak duration would give us about 2% over prediction in the delta T, the normalized delta T for the day. So we're really trying to hit 1. So actually, let's make a note of what we're hitting and seeing. Be a little bit more careful here. Okay, so 13 is just a little bit low, so let's try 14. I'm going to make a note that at the peak, we got 13, we got 99.3% for 13 hours. So 0.993 for heating, and for cooling, with 10 hours, we got 1.018. So I'm going to change the cooling to 9 for the maximum. We'll just see what that is. And for the heating, I'm going to change that max to, or the duration to 14. Calculate the responses. Okay, this looks a bit higher. It's 1.001. So that's very close. I'd say 14 would be the best there. And 10 hours was 1.018. 9 hours is 1.006. So let's go back to 8 hours is the maximum. Just move those back a little bit, calculate the peak response. Now you see 8 is 0.992. Okay, so if I just go straight out with the closest duration to the peak, right, we would probably use 14 hours for heating. That's 1.001, so that should give us 0.1% high error in the change in delta T. And for cooling, it looks like 9 hours that's 1.006, so 0.6% high. 8 would be is 0.992, so it'd be 0.8% low. So again, we're just trying to hit this one line, and you could say, if you don't want to think about it too much, you're just trying to find the duration that hits hits a ratio of delta T to the delta T max for the actual, right, which will always max at 1, right, with that. Okay, so that's the finding the durations. Now, the other thing the peak load analysis tool is actually finds these loads. So if we'll use that to get the summary data. We need to tell it here that we want the maximum over duration. Actually, we don't have to tell it the hours if we're using the maximum over duration. If we're using average over duration, it needs to know the hours. I'll just put them in anyways. But then if we get the summary data, these are the loads in kilowatt hours. Okay, so now I'm going to bring over GLHEPRO. Let's see, maybe it would be put GLHEPRO on top of a blank screen like that. Maybe easier to see. Okay, so the units here in this file so I was working in American or English units, BTUs per hour in feet. If we're going to paste the loads in, they need to be in the same units. We can always change it back if we want, but we just happen to do the Energy Plus analysis and get the results in SI units. So we need to paste them in here. Oh, okay, so apparently I've made some kind of mistake, which probably was, I lost track of what I was doing, and I forgot to copy this. So let me try that again. Now I've copied it. Now I'll come back to GLHEPRO to the loads, and I will paste them. And we said 14 hours for heating. It turns out it doesn't make any difference what the heating is because we're not going to hit the minimum design temperature. And we'll take 9 hours here. Okay. So we've done all the other inputs here, and we could actually use the sizing tool, or we could switch back to English units, and everything's been translated. The loads are now in thousands of BTUs, and peak loads are in thousands of BTUs per hour. So GLHEPRO handles all the unit conversions. So if we run the sizing tool with, in this case it was 90 and 40, we get 246.6 feet for each of our, in this case we have an 80 borehole field. If we just go back, we'll just make one change. We'll go back and change the peak hours to 0. Right now we have in effect no peak loads. If we run the sizing, right, it's 212.64, so is that about around 34 out of 250, so maybe 13% or 14% undersizing if we don't include the peak loads. Okay, so that's it for the live demo.